Wireless security options. So while you've been doing your research for wireless network equipment, you've probably seen information about securing your wireless LAN by using 128-bit WEP encryption. And you might be asking yourself, what is WEP? What is encryption? What is all this stuff about? Well, that's exactly what we're going to learn about in this module. So before we start configuring the security options on our wireless access point, we need to know what these options are and what they do for a living and the difference between them and why I would choose one over the other. So that in a nutshell is what we're going to cover in this module. And then after we've created this foundation of security information, we'll go from this information and in the next module learn how to actually configure a wireless access point. So let's get started with what information do we need to know about securing our SSID or our service set identifier. And to learn about this, we're going to bring up another whiteboard. If you remember from our previous module, we learned that the SSID is essentially just the name of the wireless network. It allows us to distinguish one wireless network from another. Most manufacturers of wireless access points have done a couple of things to allow you to easily locate and connect to a wireless access point. Number one, manufacturers will pre-configure a wireless access point by using a default SSID. So for example, if you purchased a Linksys wireless access point, the default SSID for wireless access points created and manufactured by Linksys is Linksys. Additionally, most manufacturers will configure the wireless access point to broadcast the name of the SSID as a default. Broadcasting the SSID is very similar to a radio station. It's just broadcasting out its information, its music, and everything else. And any radio that's within range and frequency of that radio station can pick up their broadcast, and you can listen to the music and the broadcast of that radio station. So what that means is when your wireless access point is configured to broadcast the SSID, it's essentially acting like a radio station. It's broadcasting out this information to the world saying, here I am, come and connect to me. And what that means to you is that any computer with a wireless network adapter that's within range of your wireless access point will be able to see your wireless network and potentially connect to it as well. Let me show you an example of this. Right now I'm connected to my own wireless network, but if I double click on my wireless network connection, I can see the wireless networks of my neighbors. So we're seeing the two things that we just talked about here, the SSID of the wireless network, and the reason why that we see these SSIDs is because the wireless access point is set to broadcast the SSID. So for example, if I select this wireless network, MS Home, its SSID is MS Home. The other wireless network, its SSID is BH4021. So this particular wireless network has a couple of knocks going against it. I can find it, it's broadcasting its wireless network, and as the note below says, this wireless network is not secure. You're not using any form of encryption at all, which we'll talk about moving forward here. So as you can see here right away, out of the box with most wireless network equipment, soon as you turn it on, your neighbors can potentially connect to your wireless network and then potentially connect to your computers on your wireless network. So what are we going to do to remedy this problem? Well, let's close out of here and get back to our whiteboard and talk about that. We will need to do two things to protect against this issue. Number one, we'll need to disable the broadcasting of our SSID so your neighbors can't discover your wireless network. But that may not be enough. If your neighbors know some of the default names of SSIDs, they could just potentially type in those SSIDs on their wireless network adapter and just do a little trial and error. See if you have a Linksys wireless adapter or a D-Link wireless adapter or a Motorola by using the manufacturer's default name. So in addition to disabling the SSID broadcasting, also change the name of the SSID as well to something unique, not your first name or your last name or something that's obvious to your neighbors. I'll learn how to perform those two tasks in our next module. So once we've dealt with those two issues, we'll need to choose the appropriate authentication option. Let's talk about that by bringing up another whiteboard. Authentication in a nutshell means to verify an identity. So for example, if you need to present your driver's license to somebody, maybe you're trying to cash a check and they ask you for your driver's license, they're doing that to verify that you are who you say you are. They're verifying your identity. Well, your computer with a wireless network adapter will also need to authenticate to a wireless access point. The two standard wireless authentication options available on most wireless access points are open and shared. Open essentially means that any computer with a wireless network adapter can request to be authenticated with a wireless access point. So the way this works is that your wireless network adapter is first going to try to identify a wireless network by using the SSID. So once it's found a wireless network point or wireless network, it's then going to try to authenticate with the wireless network. And in a home environment, open is actually fine. We can allow anybody to try to connect if they know our SSID, but we're going to use other methods to secure access to our wireless network. However, in a corporate environment, they might use other devices with a shared secret key to perform the authentication process. A shared secret key is essentially a password that's shared in common between the device that you're trying to authenticate with and your computer with the wireless network adapter. So for example, a shared key might be the word password. So you configure your computer with the word password or the shared secret key password, and then on the device that you're authenticating with, it is also configured with the shared secret key of password as well. So unless you have the right shared key configured on your computer, you're not going to be able to authenticate with the device unless you have the same key. So again, for our purposes here, we're going to leave the authentication option set at open because we're going to use some other methods for securing our wireless network, which we're going to look at right now. First, starting with Wired Equivalent Privacy, or WEP for short. WEP, or more commonly known as WEP, was designed to provide the same level of protection on a wireless network as you would find on a wired network. WEP uses a key as well to provide a means of authentication and encryption of data as it's being transmitted across your wireless network. If you're not familiar with the term encryption, let me just talk about that for a moment here. On the left-hand side, we have a document with the word hello, and this is referred to as a clear text document, meaning we can read the contents of it without any problem. However, if this document contains sensitive or secret information that needs to be transmitted over a network where people could potentially discover the contents of the document while it's being transmitted, we need a method for creating the contents of the document to be unreadable while they're being transmitted. So while it's on our computer, we can read the document no problem, but if we want to send an email message to somebody in a secure fashion, we need to take the document and convert it into an unreadable format. This changing of the document to an unreadable format is referred to encryption. So WEP provides a solution to this problem for wireless networks. WEP, using a network key in combination with mathematical algorithms, is able to encrypt a document. And once the document is encrypted, it will be similar to what we see on the right-hand side, just a seemingly random series of letters and numbers all over the place. And as a result, it's just unreadable. So by enabling WEP on our wireless access points and our wireless adapters, it will do two things for us. Number one, it'll help to prevent people from gaining access to our network, even if they can see our SSID and it is being broadcast. Unless they know the network key to connect to the network, they will not be able to gain access to our wireless network. The second thing that WEP provides is that it allows for the encryption of data as it's being transmitted on our wireless network. So in order to use WEP, you need to configure your wireless access point for WEP and use a static shared secret key. That means, static means it's not changing. It's always the same unless you manually changed it. And the shared key, it will be used to provide the 128-bit encryption that we had referred to earlier. And the whole shared network key business with WEP can be a bit confusing as well. Different companies use different formats for this key. You can use hex or ASCII or something called a paraphrase, oftentimes the shared secret key will be 26 characters to provide 128-bit encryption, which might look something like this: A, E, 0, 0, and then it just continues on for to reach a maximum of 26 characters. So nobody will be able to connect to your wireless network unless, and you included, unless you know what this key is here, this network key. So you need to configure your wireless access point with this key and then take that information and configure it on your wireless network adapter. And we'll see how to do that in our next module. Now, this static key is a bit of an issue, and some other components within WEP also are a bit of an issue. WEP has some vulnerabilities with these keys in that they're reused or they're repeated during the transmission of data on our wireless network. And what that means in a nutshell is that a hacker with the appropriate equipment can collect and analyze enough information from your wireless network as the data is being transmitted back and forth between your wireless network adapter and a wireless access point. Somebody could be sitting outside of your house or outside of your building, or your neighbor can use what's referred to as a wireless network sniffer. It's just capturing information in the ethers, in the air, and if it collects enough of this information, it can analyze the data to find out what this static shared key is. And once somebody has your WEP key, well, they've got the keys of the kingdom and all bets are off. So again, WEP uses the same static shared key for authentication and encryption, and it does not change while you're connected to your wireless network and while data is being transmitted over the wireless network. And that's one of the vulnerabilities of WEP. Well, there is a remedy to this. A new form of encryption, a new encryption option, if you will, has become available as of late, called Wi-Fi Protected Access. Let's take a look at that. Wi-Fi Protected Access, or also known as WPA, also uses a shared secret key, otherwise known as a passphrase, similar to WEP. However, in contrast to WEP, what WPA will do is after you've established an initial connection to your wireless access point using your paraphrase, it will automatically use random keys during your wireless connection. So for example, if your wireless access point using WAP is using a paraphrase of password, you will configure the wireless network adapter on your computer with the paraphrase of password, and that will be used for the authentication process. And then once you're connected to your wireless access point, it's just going to randomly change these keys to whatever it might be. It's just randomly generating through keys during your connection. And by doing this, those keys are much less susceptible to being discovered because they're always being changed on the fly. But the passphrase that's used to establish the initial connection, that's never going to change unless you manually change it on your access point and on your wireless network adapter. Another benefit of WPA over WEP is that it provides much stronger level encryption than WEP does as well. So it really helps to address the vulnerabilities in WEP quite a bit, and it's an excellent method for home users or home office users or small office users to protect their data as it's being transmitted on a wireless network. However, there are a couple of hurdles you're going to have to jump over in order to use WPA. Let's bring up another whiteboard and take a look at some of the requirements that must be met in order to use WPA. The following are the requirements that must be met if you want to configure WPA and Windows XP using the wireless configuration options in the operating system and optionally with Windows 2000. If you have Windows 98 or Windows Millennium Edition, you'll need to ensure that the software that comes with your wireless network adapter supports the ability of configuring WPA. First off, your wireless access point or your router has to support WPA, and you might be able to upgrade your existing 802.B router or access point to WPA. New 802, as we discussed before, G routers and access points support WPA right out of the box. Additionally, your wireless network adapter will also have to support WPA. You might be able to just upgrade your driver to get that support, but you might also have to purchase a new wireless network adapter, an 802.11g wireless adapter to get WPA as well. Also, your operating system must support WPA. In order to get the WPA functionality with Windows XP Home or Professional, you'll need to install Service Pack 1 for Windows XP with the recommended update 815485, or if you install Service Pack 2 for Windows XP Home or Professional, the Service Pack will include this update. So again, if you're not using Service Pack 2 with Windows XP, you'll need to install Service Pack 1 if you don't already have it installed, and then download and install the recommended update that we have listed right here. And the easiest way to obtain this update is from Microsoft's website. Let's see how we do that. We click on Start, select All Programs, then choose Windows Update. And that's going to fire up your web browser and connect to Microsoft's Windows Update website. Then on the right-hand side, you'll locate and click on the link Scan for Updates, and that's going to check to see which updates you currently have on your computer and compare that with the list of available updates. And once it's done that scan, click on the link on the left-hand side for Windows XP, and then on the right-hand side, locate the update that I had mentioned, select it, and then install it on your computer. You'll have to restart your computer, and then once you've restarted your computer, you'll get the new WPA functionality, which looks like this. Let me bring up my wireless network connection. We'll go to the properties of my wireless network connection, choose wireless network, select my wireless network, click on properties, and then in the network authentication field, we see open, shared, WPA, and WPA PSK. So once we've installed the client, we get these two new features here. But as a default with Windows XP, as I had mentioned before, you get open and shared. Now with the new client, we get WPA, which is used in an enterprise environment. And in a home environment, we use WPA PSK, which is pre-shared key. We'll learn how to configure our network adapter with WPA PSK in our next module. So let's close out of here and go back to our whiteboard. So again, this update is just meant for Windows XP computers. At the time this video was made, Microsoft had not made available a WPA client for Windows 2000. However, a third-party company has made available a free WPA client, and it can be downloaded from this website. So at the making of this video, WPA was the best option for securing a home wireless network or a small wireless network. However, if you're not able to use WPA due to the upgrade requirements, there's another security option that you can implement called MAC address filtering. Let's bring up a whiteboard and take a look at that. Every network adapter, either wired or wireless, is uniquely identified by a 12-character address referred to as a Media Access Control Address, or MAC address for short. So because your wireless network adapter has a MAC address, what we can do is build a list on our wireless access point of all the MAC addresses for all of our wireless adapters that should have access to our wireless network. Anything that is not on that list gets filtered out, and as a result does not get access to our wireless network. So this process is similar to having to present an invitation in order to get into a nightclub. You're going to need two things. You're going to need your invitation, and unless your name is on that guest list, you're not getting in. So please present your invitation. Okay, thank you very much. Let me check to see if you're on the guest list. Oh, you are, you're getting in. Oh, you're not getting in. Sorry, thanks for playing. So in order to create this list, you'll need to know what the MAC address of your wireless network adapter is. And on Windows 2000 and Windows XP computers, you can discover what your MAC address is by running the ipconfig all command from a command prompt. Let's see how we do that now by opening up a command prompt, and that's done by selecting Start, then select All Programs, next select Accessories, and then in Accessories, locate and click on Command Prompt. And from the command prompt, we're going to type in ipconfig space / all and then press the Enter key. And then from this list, locate physical address. Physical address is another name for your MAC address. And then on the right-hand side, we see the 12 characters which uniquely identify my network adapters. So this is the MAC address for my wireless network adapter. And once again, this is also for wired adapters as well. So you'd have to write that information down and then enter this information on your wireless network access point, which you'll see how to do in our next module. So let's close out of here and go back to our whiteboard. And if you're using a Windows 98 computer, you can discover the MAC address by running this command, winipcfg, or winip config for short. One thing to take note of, though, about MAC filtering is that somebody with the right equipment could capture the MAC information as it's being transmitted from the computer to the wireless access point and obtain that information and then configure their wireless access point with your MAC address, and by doing so gain access to your wireless network. So MAC address filtering is certainly not a panacea. Ideally, you should be using WPA to provide security for your wireless network. And with that, that brings us to the end of this module. Let's bring up our whiteboard and do a quick recap of what we've learned here. We learned that we need to change the name of our SSID and disable the broadcasting of our SSID. And we learned that with Windows XP, we have two authentication options as a default, open and shared. And for our home environment, we need to configure it as opened in order to use wired equivalent privacy, or WEAP protection. So we learned that WEP provides for authentication and encryption options for our home wireless network. However, there are vulnerabilities in WEP which could potentially be exploited and, as a result, gain access to our wireless network. WPA, in contrast, fills some of the holes that are in WEP, provides a higher level of authentication and encryption options, and ideally should be used in a home wireless network. If we're not able to use WPA due to equipment limitations, then we can combine the use of MAC filtering with WEP to provide the highest degree of security possible with our given equipment. And with that, I would like to thank you for viewing this module.